What if I told you there's a secret language that helps millions of mapping enthusiasts, researchers, and even emergency responders understand the world around them in incredible detail? A language that unlocks the power of OpenStreetMap data, letting you ask highly specific questions and get precise answers about places, infrastructure, and even the subtle nuances of our built environment. We're not talking about a cryptic ancient dialect, but something far more practical and powerful: overpass. You might be familiar with OpenStreetMap, the collaborative project to create a free, editable map of the world. It's like the Wikipedia of maps, where volunteers worldwide contribute to build an astonishingly rich dataset. But here's the thing: OpenStreetMap, in its raw form, is a massive, complex database. It contains everything from the smallest footpath to the largest highway, from individual trees to entire national parks. If you just wanted to find all the benches in a particular park, or every restaurant with outdoor seating in a city, sifting through that mountain of data directly would be a monumental task. This is where Overpass steps in, acting as your personal interpreter and data wizard. Think of Overpass as a highly specialized search engine for OpenStreetMap. Instead of typing a few keywords into Google, you write a query, a set of instructions that tells Overpass exactly what kind of OpenStreetMap data you're looking for, within what geographical area, and with what specific attributes. It's like having a super-powered magnifying glass that can filter through billions of data points and highlight precisely what you need. So, how does this magic happen? At its core, Overpass works by allowing you to make targeted requests to a dedicated Overpass API, Application Programming Interface. This API then goes through the vast OpenStreetMap database, finds the elements that match your criteria, and returns them to you, typically in a structured format like XML or JSON. Let's break down the fundamental building blocks of an Overpass query. It's not as intimidating as it sounds. Every OpenStreetMap object, whether it's a node, a point with a latitude and longitude, like a single tree or a bus stop, a way, a line connecting multiple nodes like a road or a river, or a relation, a group of nodes, ways, or other relations, representing complex features like a bus route or a building with multiple parts, has associated tags. These tags are key-value pairs that describe the object. For example, a road might have the tag highway equals residential, or a restaurant might have amenity equals restaurant and cuisine equals Italian. An Overpass query essentially consists of three main parts: the scope, the filters, and the output. The scope defines the geographical area you're interested in. This can be as broad as the entire world, or as specific as a bounding box defined by coordinates, or even a named area like a city or a country. You can also define the scope based on an existing OpenStreetMap object's ID. For instance, you could say, "Show me all the shops within 500 meters of this specific building." Next come the filters. This is where you specify the types of OpenStreetMap objects you want: nodes, ways, or relations, and, crucially, the tags they must possess. This is where the power of Overpass truly shines. You can combine multiple tags, use regular expressions for more flexible matching, and even specify conditions like not equal to or greater than. Want all cafes that also have Wi-Fi and are open late? Overpass can handle it. Need all parks larger than a certain area? Also possible. The level of granularity you can achieve is astounding. Finally, the output part dictates how you want the results presented. Do you want just the raw data? Do you want to see it on a map? Do you need specific attributes of the objects or all of them? Overpass gives you control over the format and content of the returned data. Let's walk through a simple example. Imagine you want to find all the bicycle parking facilities in your neighborhood. A basic Overpass query might look something like this, simplified for explanation. Area name equals your neighborhood name, -.a. Node amenity equals bicycle underscore parking, area.a. Way amenity equals bicycle underscore parking, area.a. Relation amenity equals bicycle underscore parking, area, a, winky face, out. Don't worry about memorizing the syntax right now. The important thing is to understand the logic. This query first defines your neighborhood as the area of interest. Then, it looks for any node, way, or relation within that area that has the tag amenity equals bicycle underscore parking. Finally, out. tells overpass to output the results. Overpass is not just for advanced mappers. It's incredibly valuable for a wide range of applications. Urban planners can use it to identify areas with a lack of green space or analyze the distribution of public transportation stops. Researchers can extract specific datasets for academic studies. Developers can use overpass API calls to power their mapping applications, creating custom maps based on highly specific criteria. Emergency services can quickly identify critical infrastructure in a disaster zone. Even a casual user can satisfy their curiosity about, say, the number of bookstores in their city or where all the public fountains are located. One of the most common ways to interact with Overpass is through the Overpass Turbo web interface. This user-friendly tool provides a graphical interface for building and running queries, visualizing the results on a map, and exporting the data in various formats. It's an excellent starting point for anyone new to Overpass. You can see your query results instantly, tweak your filters, and iteratively refine your search until you get exactly what you need. Overpass Turbo also offers a wizard mode that allows you to construct simple queries using natural language, which then generates the more complex Overpass QL, query language, code for you, a fantastic way to learn the syntax by example. Another crucial aspect of Overpass is its timeout mechanism. Because OpenStreetMap data is so vast, queries can sometimes take a long time to process. Overpass servers have a default timeout to prevent individual queries from hogging resources. For more complex or geographically expansive queries, you might need to adjust this timeout value within your script. Overpass is constantly evolving, with new features and optimizations being added. The community around OpenStreetMap and Overpass is incredibly active and supportive, with extensive documentation and forums available to help you learn and troubleshoot. There are even specialized libraries and tools that integrate Overpass functionality into programming languages like Python, allowing for even more sophisticated data processing and analysis workflows. With that said, thanks for watching, and until next time.